I started with this 18-inch tall, 7-inch wide glass cylinder. Using a drill and 3 diamond-tipped drill bits, I bored 3 holes in the bottom of the glass. Don't try this at home. In 2 of the holes that I drilled in the bottom, I threaded this 1/2-inch flexible piping with 90-degree PVC elbows. Next, I went back and sealed around the PVC elbows where they met the glass, and sealed them, and sealed them. These 2 submersible fountain pumps have a max flow rate of about 80 gallons per hour. Because these pumps have to stay submerged in water, I used a plastic tote filled with water, and then I put the glass cylinder on top of a flower planter. When I built the vortex, I placed the elbows parallel to the sides of the cylinder facing in opposite directions of one another. Here I'm taking advantage of Newton's first law. Water being pumped in will try to travel in a straight line until something changes its direction. In this case, the water will hit the wall of the cylinder. The direction of the velocity is forced into a circle. This is called centripetal acceleration. Now we're going to jump to Newton's second law. Newton's second law defines the force as the mass times the acceleration. Since we're using centripetal acceleration, A can be rewritten as the velocity squared over the radius. Our force now becomes F is equal to the mass times the velocity squared divided by the radius. Because water is being pumped in from the bottom, it can only overcome gravity for so long. At height h, the potential energy of the water is converted into kinetic energy. So instead of traveling around the outside of the cylinder, water begins to move inwards. Ignoring really small frictional forces, the angular momentum of the water stays the same as it moves inward. To conserve angular momentum, the water's velocity increases as its radius decreases. This means the water that's leaving is moving faster than the water that's being pumped in. All of these forces sustain a pretty neat vortex. Thanks for watching this video. Hopefully I'll have a couple more up soon. But in the time being, you guys can follow me on Twitter and on Facebook at Bluegrass Science.